Hi guys, it's Miss Griffin. We're looking at Unit 7, Skill 2, deriving the equation of a circle. So your essential question's written there. It says, what is the equation of a circle and what do the components represent? So after you write that, we've got to talk about a couple parts of circles. So first, we're defining what a circle actually is. This is the official definition of a circle. It's a shape with all points that are the same distance or length from its center. That distance or length is called the radius. So let's sketch a little picture of a circle. You know circles from elementary school, right? Circles are called by their center. So if this was center O, it would be called circle O. If it was a Q, it would be called circle Q. Then we also have these things called radii, which is plural for radius. The radius goes from the center to the outside of the circle. It's a segment, and we label it as R. We also have something called a diameter. You do need to know all of these things in order to be successful in this unit. So diameter is twice the length of the radius, meaning that we've got a center, say O, and the diameter goes all the way across straight through the center. I didn't draw that very well, but it goes straight through the center. And it's equal, again, to twice the radius. So here we have little r, but then the whole piece is 2r, or in other words, d for diameter. So when we talk about circles, we have this special equation written in standard form. And so you should probably box this in or highlight it. It's super important to remember. It says that we've got x minus h squared plus y minus k squared equals r squared, where h and k represents the center, and r is the radius. Notice that everything gets squared, right? These little squareds are on here. You can't forget those in your equation. You do have to memorize this, by the way. And you have to know the right order, too. So our first example says, write the equation of a circle whose center is 1, negative 2, so this represents h and k, and the radius is 5, and then sketch a graph of this circle. So we're going to actually sketch the graph first, and then we'll write the equation afterwards. It says the center is 1, negative 2, so go ahead and plot that. And then with a radius of 5, that means I stretch out 5 in all directions. So I go to the right from that 5. And again, it's from the center of the circle, not from the origin, but from the center of the circle. And then I go up 5. Then we have to go to the left 5. And lastly, down 5. So when you connect these points, after making essentially all your radii, we're going to sort of make it as circular as possible, right? You could connect them and make a square, but we don't want a square, we want a circle. So now we have to write the equation of this circle using the center and the radius. So remember that it always starts with x minus something squared plus y minus something squared equals the radius squared. Those somethings, again, come from the h and k from our center. So the first value goes with x, second value goes with y. So x minus 1 and y minus negative 2. And then, of course, the radius of 5 gets plopped in here and becomes squared. So now I'm going to rewrite this because we don't like double negatives and we don't want to just leave 5 squared. We want to write out what it's actually equivalent to. So this one just carries down the same way because there's no double negatives, nothing else to do. X minus 1 squared. But then this double negative turns to a positive, so we have plus y plus 2 squared equals 5 squared, which is 25. So now here we have the equation of a circle using the center and the radius. So notice what happens when we have the original h was positive 1, and now it's a negative 1 in our equation. Our original k was negative 2, and now it becomes a positive 2. So there's a quick trick when you're writing the equation of a circle. And we're going to jot that down off to the left-hand side. So our trick is to switch the signs of the center when plugging in. To the equation. Switch the signs of the center when plugging into the equation. So we've got this second example here. It says, write the equation of a circle whose center is -2, -4, and the diameter is 6. So if you recall, the center represents your h and k, and we need the radius in order to write the equation of a circle, right? We need center and radius. Well, here they gave us the diameter being 6. So again, diameter goes all the way across through the center of the circle. So this whole piece is 6. But remember that the radius is only half of it. So in other words, r equals 3. So I want to be using that when I plot the circle and when I write the equation of a circle. So I'm going to start by plotting -2, -4. That's the center. And then I'm going to use the radius of 3 to go outwards, upwards, downwards, sidewards, whatever you want to call it, right? And then I draw it in. And again, don't forget to try to make it as circular as possible. If it's not perfect, that's okay. Nobody's going to deduct points from you, but try to make it the best you can. All right, so writing the equation, again, requires the center and the radius. So I have to start with my basic structure, parentheses x minus something squared plus parentheses y minus something squared equals blank squared. And in that blank goes the radius, so let me plop that in there right now, 3. And remember that all we have to do is switch the signs for h and k. So this was a -2, now I'm going to change it to a +2. This was a -4, so now it's changing to a +4. I could go through the process of like the whole double negative thing again, but why, right? If I know that a double negative will automatically turn to positive, I don't need to go through that process. So now rewriting, because again we don't like 3 squared, we want to rewrite this as x plus 2 squared plus y plus 4 quantity squared equals 3 squared, which happens to be 9. Box it in, and that's your answer. Flip it to the next page so we can see another type of problem. Okay, so this next example actually came from a Regents exam. It says the graph below shows AB, which is a chord of circle O. So, P.S., a chord is what we see over here in this picture. It's a segment that connects 2 points on a circle, but it does not pass through the center. So, you know how a diameter passes through the center? Well, this is just passing not through the center. It says that the coordinates of the endpoints of AB are A at 3, 3 and B at 3, -7. The distance from the midpoint, this is important, distance from the midpoint of AB to the center of the circle is 2 units. So if I look back at this little picture here and I talk about the midpoint of AB, the distance that it is from the center of the circle is 2 units. So I know that I could have this circle where I have, say, center 1, that's just a way to label it, and AB is on the left of it. Sorry, the right of it, oh my goodness. And that midpoint is 2 units from it. Or I could have a circle with center 2, again, just a way to label it, center 2, where AB is the chord on the left of it. And the midpoint of AB is, again, just 2 units from center 2. So I know that I could have 2 potential centers here. So I'm going to plot those centers on this graph. But first I have to find the midpoint of AB. To find that midpoint, all I have to do is count how long this segment is. So we'll count it right now. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so halfway would be 5 away. So I'm going to plot that midpoint right here. I'm going to keep my color scheme going so that you can like match those parts. And then I need center 1 and center 2 to be 2 units away from that midpoint. So one of them will be here, that's center 1. And the second one will be here, that's center 2. The reason I went to the left and the right is because my line segment goes vertically. This chord is vertical, so I don't want to go up 2 units because then I would land on the chord and that wouldn't represent the center, right? If I took the midpoint and went up 2 units, that's not the center of the circle. So if my chord were lying horizontally, I would go up 2 and down 2. It just depends on the way in which your chord is lying. So now I have to find out what value I need on the right-hand side of my equation to represent this radius. Right, so this is radius squared, so I need to find out the length of that radius by connecting my center to one of those points. I'm just going to connect it to A. You could connect it to B if you wanted to. Now again, we know this distance down here is 2. I could count this distance to be 5. And now I want to know the length of this radius. So recall that when you have a right triangle with 2 sides and you're missing the third, you can use something called a squared plus b squared equals c squared, Pythagorean theorem, to find that missing side. Where c is always the hypotenuse and your a and your b are the legs. So we have 2 squared plus 5 squared equals r squared. Well, 2 squared and 5 squared are 4 and 25, so that makes 29 equals r squared. So I'm going to get rid of choice 3 and 4 because that had 25 and that's not okay. Then my next step is to take a look at where the centers are actually located. Center 1 was at 1, -2, and center 2 was at 5, -2. I'm just counting those numbers from the origin, right? Over 1, down 2, over 5, down 2, from where I originally plotted them. And remember that when we plug them in, we have to switch the signs when plugging in. To that center radius circle equation. So this +1 needs to become a -1. So I look at choice 1 and, ooh, it's a -1. That's good. This -2 needs to become a +2. Woohoo! It looks like choice 1 might be a winner here because it switched the signs and it had r squared at 29. If I look at center 2, it's a +5, meaning I should see a -5 in the equation, but guess what? They kept the sign. So choice 2 is automatically not okay because that sign needs to change. So that leads us to believe that choice 1 is the correct answer to represent the equation of this circle. And yes, this is harder than the first 2 examples because you actually have to do some work to find out where your centers could be and where your radius or how long your radius is using Pythagorean theorem. So don't forget about Pythagorean theorem. Right, this is from skill 5.6. So if you are struggling, go back to skill 5.6 to learn Pythagorean theorem first. Okay? If you've got questions, let us know. Otherwise, get working. Practice problems.